be hilarious.
Well, what's your graph look like?
Well, we got a absolute value graph, so next to V.
So something like that?
Yep.
And then you could call this would be like point A.
And then B, and then F of A.
Yeah, so the height at A is the same as the height at B.
Yep.
So F of A equals F of B. But the derivative, well,
Yeah.
there. But the derivative's never 0. Usually at a min or a max, the derivative is 0. But at this min, the derivative is
Undefined.
undefined.
I have another idea.
You have another idea?
Yeah. A parabola, but like where it would be 0 would open.
Oh, bam.
What up?
So you're saying,
I don't know. But then they would open.
yeah, if we had this, it's close, but here the derivative's 0, so you're saying just open that thing up, and what's the derivative at that point? Undefined. Yeah.
And then just two intersecting line segments.
Well, that's kind of, I thought that's what you're driving at with this thing too, right? Kind of the same.
I went all the way through.
Alright. If you did that, that would, same idea,
Yeah.
it would cease being a function, is the only thing, because it would pass the vertical lines. But I think that's kind of on par with that, right? There you go. These are the two ways to screw up that challenge. Well, not screw it up, but to win it. You'd screw it up for the person offering the challenge, which I guess would be me. Oh. I can take it though, I'm already. But no, I'm, yeah. So Rolle, when he came up with Rolle's theorem, he said, gee, it sure seems like whenever a function starts as high as it ends over some interval, it sure seems like there, at some point there has to be a derivative of 0. And then probably someone came along and said, no, 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 what if you got this? Because you know how it is, there's always the person, well, what if blah, blah, blah. Everyone knows that person, right?
Yeah.
Maybe you are that person.
Right.
There's always the person, well, what if you had a sharp turn? Or what if there's a hole at that point? You know, but that's good. Those kind of people, as annoying as they can be, also, you know, push people toward improving things or fighting. Alright, so what Rolle's theorem says, when Rolle was all done revising his theorem and bouncing it off his contrarian friends, Rolle's theorem ended up saying, if you got a function over some interval that starts as high as it is when it ends, then, then he had to put in a couple ands, and it's differentiable over the whole interval, then you can guarantee that the derivative has to be 0 somewhere in that interval. Alright, so let's write that out. So there's 3 prerequisites for Rolle's theorem to work. First prerequisite, the function has to be continuous between the endpoints. That's kind of the most trivial of the 3. Oops. F is continuous on A to B, not necessarily including A or B. I'm sorry. Do include A and B. I'm getting ahead of myself. So you couldn't have, that would prevent you from having like this. Oh. You know. And F is differentiable everywhere in between A and B. So it doesn't necessarily have to be differentiable at the endpoints, but everywhere in between it does. And what's the third prerequisite? Well, that's going to be the punchline. That's going to be the conclusion.
The endpoints.
Yeah, the endpoints have to be at the same height. So f of A has to equal f of B. If all that's true, then, and that's where the whole derivative being 0 comes in.
Are those what, like for 2, is it supposed to be parentheses or is it supposed
Yeah, that is supposed to be parentheses. Because if these were brackets as well, I could just consolidate 1 and 2 together.
Oh,
Because if
okay.
it's differentiable, it's automatically 2. So 1 and 2 are kind of, 2 is really the bigger issue. And there's probably some technical, this little technical counterexample here would make 1 apply. Then there is a value C on the interval such that so there's some x value, call it C, on the interval that what?
That's equal to 0.
If you do what with it?
If you derivative.
But this is
So, okay, f prime of C, yeah. If you plug C into the derivative, you would get 0. Alright, so the problems that go along with this are pretty much just, here's a function, here's an interval. Can you apply Rolle's theorem? Which means, is 1, 2, and 3 all true for that function in that interval? If you can, then find the value of C where the derivative is 0, because there should be one. If you can't, then state which one of these things it violates. So they're pretty straightforward problems. It's just using the theorem. Let's look at a couple examples.
alright.
We got both. Probably almost.
Can we apply Rolle's theorem? If so, what is C? If not, why not? I guess we have 3 examples. They're so quick, I didn't even see the third one. Actually, I didn't see the second one. I thought it was part of the first. We got f of x equals absolute value of x minus 1 on negative 1 to 1. So we got our function, absolute value of x minus 1. Our a is negative 1, our b is 1. So eventually if our answer is yes, we're going to want to come up with a value between negative 1 and 1 to answer the question. If our answer is no, we're going to want to say which one of those criteria, or which one of those prerequisites it doesn't live up to. So let's go through the checklist. Is this, think about what this graph looks like. What does it look like? It's a V. Any holes in it? Nope. Okay, yeah, a quick sketch of this will give you something like that, right?
Yeah.
So it is continuous. Is it differentiable?
No, it's
Edit
not.
it. Top breath.
Edit that right out.
Very sensitive about these problems. Rolle and I, we used to be like that. All right. Until that combine accident. Is it differentiable? And I know it's not differentiable everywhere, but is it differentiable on that interval? No. It's got a sharp turn when x is 0. So what's our answer? Okay, our answer
Because
is
of
no.
rule 2.
Yeah, it's not differentiable at x equals 0. So you want to say specifically where the problem is. It's not differentiable because the derivative does not exist. That's what it means to be differentiable. Does the derivative exist? Well, at 0, it doesn't because it's a sharp turn.
So what we did earlier was like the parabola with the hole in it and the V. That's not.
Those would be nots.
Alright.
And the reason would be because of one of these 3 criteria. Actually, both of those are because of this.
Yeah.
Yeah. No, because different books will say have them in a different order. In fact, I probably year to year write them in a different order myself. So just say specifically why. Just 6 months from now, you won't remember what 1, 2, and 3 are, but you'll remember what differentiable means.
I remember.
How is that okay? Because
This thing's not okay.
oh, okay.
Yeah. So these were counter examples.
Okay.
All right. Let's do another one.